So in this video, we're going to talk about the biodiversity crisis, and it truly is a crisis, which we're going to talk about later in this video, but I think the biodiversity crisis is where environmental scientists and ecologists kind of lose public support or public understanding, because I think the public really and truly does not want to believe that we are experiencing a biodiversity crisis, and so they don't really listen to the facts that are presented or the science behind it. And they don't really realize the severity of what's going on. And that's kind of why I'm making this video, is to kind of try and explain a little bit more what is happening and why this is truly such a danger to the way we live our lives right now. So first, I think we should start by looking at what contributes to biodiversity. And biodiversity just means the variety of life in an ecosystem, or globally, or something that's not a monoculture. You don't only have one type of species in an ecosystem, you have many, and that is what biodiversity is. So in this ecosystem, we can kind of identify a few factors that would contribute to a high biodiversity, and that's what we're going to look at first. What makes biodiversity increase, or what contributes to a higher biodiversity? So the first thing that we have is going to be insolation. Spelled S-O-L, not insolation, insolation, which means high amount of sunlight, which is going to lead to temperature. And this does not necessarily mean a specific type of temperature. This could be a low temperature, like if you were in the North Pole, or this could mean a high temperature if you were in the desert. Basically, whatever temperature that is going to correlate to the most number of species that are comfortable, or the optimum temperature for the most number of species in that ecosystem. So the optimum temperature in a rainforest would not equal the optimum temperature in, a desert. And that's going to correlate to whatever amount of insulation. Once again, this does not necessarily mean a high amount of insulation. This just means a optimum amount of insulation for whatever, for whichever species are living in the ecosystem. Alright, so the next thing we can look at is water. So availability of water and dissolved oxygen, which would be for the fish. If there was not enough dissolved oxygen, you could not support a large amount of marine life. But even if you didn't have marine life, availability of water is a crucial part of biodiversity. The more water you have, the more animals you'll be able to support, the more organisms. So that's pretty crucial, is the availability of water in an ecosystem. And then in terms of terrestrial life, soil nutrients is really important to sustain plant life, and which will sustain animal life, as we saw in the trophic levels. So that's pretty important to biodiversity. And then also just space. If you have a lot of space in your ecosystem, obviously you can have more animals, different kinds of animals. There's room, there's niches for all these different types of animals to thrive. So those are some of the main factors which contribute to a large amount of biodiversity. But what happens is that when you are severely lacking in some of these factors, biodiversity will decrease. And sometimes biodiversity will decrease so drastically that it causes an extinction of one of the species, or at least an extirpation. And an extirpation is, here, I'll write it down. To extirpate means to have an extinction locally. So if you had an extinction only in California, but there were still animals of that species living somewhere else, it would be extirpated in California, but it wouldn't technically be extinct. So that's what that is what will happen if we decrease biodiversity of an ecosystem too much. And so let's look at what exactly causes extinctions and extirpations with this acronym. This acronym is pretty well known, and it's pretty universal, HIPCO. You may have heard it as HIPPO. They added the C, and you'll see kind of why. So let's just look at what each of these means. So this is going to be an acronym for what causes extinction, or the main causes of extinction. So the first cause is habitat loss. And this is pretty important because I would even say this is the biggest reason for the cause of extinction. Because if an animal doesn't have a place to live, then it is going to become extinct. Because animals are really very specialized for the most part. Case-selected animals are pretty much specialized. And if you take away their habitat for whatever reason, they really don't have anywhere else to go. A great example of this is the orangutan and the forests in Indonesia and other tropical countries like that, where we are cutting down the rainforest to harvest mainly for palm oil. And that is creating a huge decline in the orangutan population, and it will probably lead to their extinction. Pollution, which we'll get to, but that can also lead to habitat loss. A lot of these are pretty interconnected. So the next one is invasive species. And I don't know how much you know about environmental system or ecology, but invasive species may be something you've heard about, and you kind of gave it a thought, and you didn't really think much of it. But invasive species is probably one of the biggest problems that we face in terms of the environment. Because, like I said, a lot of K-selected species are specialized, but then there's R-selected species, which are not specialized at all and can thrive in a lot of different environments. And these R-selected species are things like beetles, ants, I think all insects are R-selected. A lot of reptiles are R-selected. K-selected is mostly mammals. But when we put R-selected species in certain environments, they will take the food, they will take the water, they will take the nutrients of all the other species and cause extinction. And there's so many invasive species in America, it is incredible. And it's not good, and a lot of people think, you know, oh, it looks nice or it's for aesthetic reasons, but in reality, that is how we kill the native species. And that's a really big problem, and I'll kind of explain to you. If you're in California right now, you know that we're in a drought, we're in a state of emergency. And it's interesting because native species of California, native plant species, would be okay right now. Because native species of California do not require a lot of water, because California is a pretty dry state. But because we have planted so many invasive species and non-native species that require water because they were evolved to be in a climate where there was higher water or water availability, we have to spend so much of our water taking care of these invasive plants in our lawns or our yards or our parks, when in reality, had we just let nature use its native species, we would have been able to save that water. And so that's just kind of one example of why invasive species are so bad for the environment. Now, keep in mind, an invasive species somewhere is a native species somewhere else. So really, it's not that they inherently are bad, but nature has found a way to allocate resources to species on its own. So we should not be messing with where these species are located and what kind of resources are available to them. Okay, so the next one is pollution. And pollution and habitat loss are pretty interconnected. Pollution can often lead to habitat loss, and it's a really big problem. The Chinese river dolphin is a good example of where pollution is completely destroying a certain species, and you should Google it. If it's a beautiful animal, and pollution of the rivers is causing, you know, their extinction in the very, very near future. They will be extinct. All right, and the next one is population. I feel like this is one where they tried to just kind of make it fit. Human population, really, which is kind of human activity, you know, building houses, cutting down trees for paper, that kind of thing, would be human population. Also pretty related to habitat loss. And then the next one is climate change. So this is kind of new. The idea of climate change is not new, but I think they're realizing that this is one of the biggest, this is going to be a huge cause of extinction in the near future. The polar bears is probably the best known example. But there are countless other examples of organisms, and once again, pretty related to habitat loss, where their habitat is being affected or they themselves are being affected because of climate change. And then overharvesting, which is again kind of related to human population, but it's basically when humans over-harvest any type of animal. Okay, so now I want to talk about some of the facts. And I titled this kind of dramatically, but I think that it's really important that we kind of look at some of the facts. And these are not things that I made up, these are facts. And so I just kind of want you to think about them and what they mean in long term. So a lot of people will say, oh yeah, you know, we're having extinctions, but extinctions are natural. Things have been going extinct since before humans got here, so we really shouldn't be that worried. And they are correct in the sense that extinction is normal, but only to a certain extent. And this is what's called background extinction. And I'm going to talk about what we've done to background extinction with human activity in a second. But basically, decline in biodiversity due to human activity is progressing more rapidly in the past 50 years than at any other time in human history. Okay? Over the last 100 years, human-caused extinctions have multiplied by 1,000 times. And this is where background extinction comes in. Yes, background extinction exists, but we have multiplied it by 1,000 times in the past 100 years, and that is not normal. Current estimations of species loss ranges between 15 to 50% in the next 20 to 50 years, which means that in the next 20 to 50 years, we will probably lose 15 to 50% of the species that currently exist. And you might think this is a big range, and you're right. And what end of the range we end up on in the next 20 to 50 years is dependent on what we do to stop this biodiversity crisis now. And this is probably, I think, what really, when I learned this fact, what really kind of got me thinking, which is that what we're in now is predicted to be the 6th mass extinction. What do you think was the 5th mass extinction? The 5th mass extinction was when the dinosaurs went extinct. We are approaching the same level of extinction as when the dinosaurs went extinct and all the other animals and species that went extinct along with them. That is what the rate of extinction we are causing is approaching. And so that is something to think about, I think, and I think that's something that you might want to kind of look at, and you can always Google or look in your textbooks for, you know, more facts about what the biodiversity crisis is and what's kind of causing it, but I think that those 4 facts that I chose were probably what I think hit home hardest for me, so I thought maybe they'd have a similar effect on you guys. So now I want to talk about the Simpson's Biodiversity Index, and this is just a way to measure biodiversity in an ecosystem. And chances are, if you're in an ecology or an environmental science class, you're going to be required to know what this is. So I just thought I'd go over it in this video. It just kind of seemed along the same topic. So Simpson's Biodiversity Index is measured in this formula. Biodiversity equals n times n minus 1 over the sum of little n times little n minus 1. N is going to be the total members of all species, and little n, is going to be the number of individuals in each species. And so this really takes into account richness and evenness. So richness is going to be the number of different species in groups, and then evenness is going to be the spread between groups. So for example, if I have 25 different species in an ecosystem, but I only have 1 member of each species, and, you know, for 24 of them, and then I have 100 for the 25th one, that's not a very evenly spread ecosystem, and that's probably not very biodiverse. Where on the other hand, if I only have 2 types of species and I have 50 members of each of them, that's not a very rich ecosystem. So it kind of takes a balance between those. So let's look at an example. So let's look at ecosystem 1. And then we'll do ecosystem 2. Okay, and then let's say there are three species for this example. A, B, C. Species A, B, and C. Okay, so those could be something, you know, like rabbit, deer, insect, I don't know. And of course there'd be more species. There'd have to be producers and consumers and decomposers and whatnot. But for this example, let's just say there's species A, there's species B, there's species C. And let's say in ecosystem 1, there are 50 of species A, 61 of species B, and 2 of species C. And then let's say in ecosystem 2, there are 7 in A, 10 in B, and 11 in C. Alright, so let's see which of these is more diverse. So the first thing we're going to have to do is add up the total number of organisms in each ecosystem. So for ecosystem 1, that's going to be 113 total. And then ecosystem 2 is going to be 28 total. Okay. So now let's look at the formula. So this is the formula, and big N is going to be this number, the total members of all species. So for ecosystem 1, I'll do the formula in this color. It's going to be 113 times 112, or 113 minus 1, divided by, so sigma means sum, and so of all of the number of individuals in each species. So it's going to be 50 times 49 plus 61 times 60 plus 2 times 1. And that is going to equal around 2.1. And then let's look at ecosystem 2. So ecosystem 2 obviously has less organisms, but let's see how that even affects the biodiversity. It's going to be 28 times 27 over 7 times 6 plus 10 times 9 plus 11 times 10. And that is going to equal 3.12. So what we see is that even though there are less total organisms in this ecosystem, because they are more evenly spread out and the difference between the numbers is smaller, we get a higher biodiversity number.